infra projects so so strongly. The reason is very obvious. If we see this graph, this blue line and this orange line. So blue line shows the variation of growth of population since 1955 to till 2020 in 5 years, 10-year interval. So we can see in 1955 the global population was 2.77 crores, and now it is after 50 years, around 50 70 75 years, so, we are 779 globally. If we see the scenario of India, in 1955 it was 41 crore, now it is 138 crore. So there is almost three times increase in the population within a time from 1955 to 2020, around 65 years time. So what we are seeing that there is a huge population growth across the globe, and just to cater such type of growth of population, we need to construct many infrastructures. We need to develop many infrastructures. We need to develop many cities and all just to cater the population. So from 277 to 279, 779 crores population growth, we were compelled to create vast growth in infrastructure. So global economic growth that also balances the gap of demand and supply of the infrastructures. Of course we grew economically also, then only we can develop the infrastructures. So for catering such a large population on the globe, what we don't need only roti kapda and makan. We need now a time, we need even mall also, good quality continuous supply of electricity, continuous transportation facilities, and safety of the country also. So what we need, buildings that can be a residential building, commercial building, mixed land use building, means clubbing residential and commercial both. So for this we need low rise, then high rise building, then again scrappers also were needed. Just to transport from one city to another city, and even in the intra-city transportation, we need road, airport, ship, and railways. For these infrastructure of transportation, we have to construct tunnel, bridges, flyover, viaduct, and other allied structures required for the rapid transportation of the people and goods. And for this we need power also. Power can be generated using many modes like hydropower, thermal power, wind power, and solar power. For generating power from hydropower, again we need some infrastructures like dam, tunnel, then powerhouse. For the thermal power creation, we also need a powerhouse. For the solar power, we need infrastructure for solar power installation, solar panel installation. For the wind energy, we need to install the wind turbines, etc. And for those, we need the infrastructures. Now, for transmitting the powers, we need transmission tower and substation for distributing the power among the users. Now since we are having we are having different countries and country boundaries, and due to some competition and all, we need our safety also. So for the safety of the defense persons and equipments, we need bunkers as a storage space. So for such a large population growth, we need large rapid creation of infrastructure. So all civil engineering structures that shall base their foundation on the soil. Soil is a natural and very heterogeneous material which demonstrated different characteristics spatially as well as with the depth. So the stability of these structures completely rely on the characteristic of soil encountered. Hence, it is of the utmost importance to understand the soil and their engineering behavior. So for that, we need to do the subsoil, yeah, subsurface investigation. So now, how to define the site investigation means it is the process of determining the layers of natural soil deposits that will underlie a proposed structure, and their physical properties are generally referred to as site investigation. Broadly, we can say subsurface material consists of three types of material. One is the soil, another is the rock, and the third one is the intermediate geomaterial. So rock, that is the weakest material, weakest natural material. Rock is the strongest natural material, and intermediate geomaterial, as its name suggests, its strength is between soil and rock, means it is stronger than soil but weaker than the rock. So all subsurface material can be classified, yeah, can be found in three types: soil, rock, and IGM. So after geotechnical investigation, what we get are geotechnical investigation program offers type and depth of foundation, in which the evaluation of the load bearing capacity, then estimation of the probable settlement of a structure, establishment of construction method for changing subsoil condition. Then we can estimate the lateral earth pressure for structures like retaining wall, seat pile, bulkhead, and breast cut. And after the investigation, we can determine the potential foundation failure in case of expensive soil or collapsible soil or sanitary landfill and so on. So we have to go for the geotechnical investigation, such that so that we know each and every property of the subsoil strata at which we are going to construct the structure for the infrastructural projects. So for that, we go for the subsurface exploration program, which consists of, initially it is the collection of all available information, whatever information is available visually as well as documentarily, that we have to collect. Then if there is a requirement of any special type of foundation, that also should be known. Whether we are going to construct a bridge, if bridge is supposed to be very heavy structure from the structural construction point of view. So for the bridge, we should know the type and span length, so as well as the pier loading, what amount of loading is going to be applied on the ground. Accordingly, we have to design the foundation. So we do the study the existing adjacent structures, just to explore any effect of existing structural influence on the upcoming structure. So preliminary investigation is done after conducting few boreholes, then few test pits, then possible location of the groundwater table. From the preliminary investigation, we get this information, and on the basis of this and our structural requirement, we go for the detailed soil investigation. So we go for the detailed soil investigation, which should be confirmatory in nature and determine the additional sample requirements. So for conducting the investigation, what we need to know, we need to have the idea of up to what depth we are going to do the investigation, and up to what extent, footprint wise, what will be the investigation quantity. So the depth of investigation, that is predetermined depending on the type of structure and type of anticipated type of foundation coming on the ground. So the estimated depth, that can be changed during the drilling operation. Suppose during the drilling operation, we get some loose pocket or some specific feature of the ground. So we have to increase the depth of investigation. And to determine the approximate minimum depth of the boring, we should have the certain guidelines. So what are those guidelines? The basic guideline is that our investigation should be done up to the depth of influence, means up to where the depth up to which the structure is going to insert a substantial amount of loading. So up to that depth, we have to do the investigation and we have to do the boring. Suppose this is a isolated footing. Pointer. Suppose this is isolated small strip, small footing. So for this, up to what depth we have to go for the investigation means this will be the influence zone. So up to this depth we have to do the investigation. Now, in general, we can say if deep excavations are anticipated, at least 1.5 times the depth of investigation in case of only excavation, and is to be done. And sometimes soil conditions are such that the foundation load may have to be transmitted to the bedrock. So in that case, we have to do the investigation up to 3 meter into the sound rock and around 5 to 6 meter in the weathered or weak rock. So that's why that's how we decide up to what in depth we have to do the investigation. Now, what should be the spacing of the boreholes? So there is no hard and fast rule, but for the spacing of the boreholes, the basic philosophy is that we should get the minimum variation. Minimum means uniformity in the subsoil data, or we can conclude some data ki this data will represent the entire area. So up to that we have to we do, up to that extent we have to do the investigation. But some general guidelines are available. Suppose we are going for the multi-storied building, then we have to do the we have to keep boreholes spacing as 10 to 30 meter. If it is a small one-story building in our industrial plant, then spacing can be even up to 60 meter. For the highways, it is 250 to 500 meter. For the residential subdivision, it's again 250 to 500 meter spacing, boreholes spacing. And if we are going to construct bridges or flyovers, then at each pier location or each significant point, we should do the investigation. So this is how we decide the depth of the investigation as well as the spacing of the boreholes for doing the investigation. So now I will go for one video which will show you how this field investigation is done. This is a typical boring site, typical site where investigation is being done using the tripod and this cell and auger method, and the investigation is being done in the LFBM strata. Each video was coming.
Yes, yes.
Okay. So this is a typical video showing the investigation process, drilling process. Now these are the boring tools: auger, post hole auger, helical auger. Then another type of boring, vast boring, which is rarely used. And I'm saying it is rarely used or least preferred because we cannot get the proper strata, proper subsoil strata. So this is not a very preferred method of doing the investigation. Now this is thin wall tube sampler just to collect the soil samples, and then this is piston sampler. And this is the process how we get the soil samples. We take out the soil sample from the piston sampler. Now we come for the disturbed and undisturbed samples. So soil samples are of two types, disturbed and undisturbed. Disturbed is when the area ratio of the sampler is less than 10%, then it is undisturbed. If it is more than 10%, then it is disturbed samples. Thicker the wall, greater is the disturbance. So from this such type of sampling, we always get the disturbed sample, which is used for classification or index classification purpose and index properties only. This is a split spoon sampler. It's if we collect the if we calculate, then we find the area ratio is 112%. So this from this we get the disturbed sample only, and which can be used for the classification purpose only. Now common sampling methods. See, these are the samplers, different samplers, and the type of soil we get, whether it is disturbed, undisturbed, or partially undisturbed, and in what type of soil type layers we use such type of sampling, method of sampling, and the method of penetration is given, and then how much it's there in the investigation industry. So if we go for split spoon sampler, split barrel, then we find that it gives a disturbed sample. We get the disturbed sample only. It is used in sandy, silty, and clay strata, alluvium type of strata. And method of penetration is hammer driven. And 85% of the samples are collected using this method. So we can say it is a most versatile method of collecting undisturbed sample and doing the field test um, throughout the world. So other method or samplers are having a very less contribution in the industry. So we can say from this table ki SPT is very widely used method of collecting the soil samples. Now let's see what is the history of SPT. In 1902, Charles Gow of Gow Construction, he used 1-inch dia drive sampler driven by 110-pound hammer. Again, after 18 years, in mid-20s, split spoon sampler introduced by Sprague and Henwood of Scranton, PA, in which 2 to 3.5-inch diameter tube were used. In 1927, Gow used 2-inch split spoon sampler, recording blows to drive 12-inch with 140-pound hammer and 30-inch drop. Again in 1947, Terjagi questioned the Raymond sampler as the standard penetration test at 7th conference of SMFE. In 1948, Terjagi and Peck published first SPT correlations. In 1958, ASTM adopted ASTM D1586, in which this SPT was adopted. So this is the history of SPT. Now let's see how SPT is done, a video which will tell using the auto trip hammer. Just see, we are fixing, this is the hammer. We are pulling it up and then lifting from a predefined depth. We are giving a free fall. Just someone is counting the number of blows required to penetrate the sampler up to 45 centimeter depth. Out of that, we do the we count the number of blows for the 45 centimeter penetration, and for the last 30 centimeter penetration, the number required is the SPT number. Now this is another SPT hydraulic hammer using the hydraulic hammer. I have got this video from Patsarthi. So I will show it to you also, okay, how this hammering is again automated and refined in a refined way, we are giving the blows to get a correct or more precise SPT number. Yeah. Now, another SPT a method of doing the SPT test using this hydraulic hammer with which is this machine is used for the bullet trains. So just see. See, this is fully automatic. Transferred energy is measured and corresponding to 60% of the energy transfer. The corresponding number of blows are recorded as SPT number. So this is a more sophisticated way of getting error-free SPT number. So all these three methods are for conducting the SPT test and depends ki what project can afford. So of course the first one was very cheaper and the last one is this one using the hydraulic hammer with the fully automatic hydraulic hammer that is costlier. So another field test, many field tests are available: SPT, VST, vane shear test, then pressure meter test, then CPT, then DMT. These are the methods which are used to do the investigation. Now cone penetration test, that also is done, and in this the continuous penetration of the cone is done using the pressure gauge, and with that we get the this cone resistance, and that is correlated with the parameters of the soil. So typically friction ratio, we get the friction ratio and the cone resistance, and then we are having the SCPT correlations. For the clay it's Cu, and in sand we can get E value using the this SCPT data. So phi also from SPT or CPT in granular soil, using this graph we can get it from the field test, and we can use the soil parameter for calculating the bearing capacity and all. Now rock core drilling. This is hydraulic machine which is used for conducting the drilling work in rocky strata. So Voltas 90, this machine, it comes with the different size of casing used, that can be used PX size or HX size or NX size, to avoid any obstruction created by the bigger size broken pieces of rock. Now I will show a drilling in rocky strata. Just students can get a feeling of how drilling is done in the rocky strata. Now, different parts done with either tungsten carbide or diamond core bit. Use a double or triple tube core barrel when sampling weathered or fractured rock used to determine rock quality designation. Now, rock sampling is done with in this way. Rock cores are necessary if the soundness of the rock is to be established. A small core tends to break up inside the drill barrel. So that's why we use double tube or triple tube barrel. Large cores also have a tendency to break up, especially if the rock is soft or fissured. So this is the rock coring barrel used for taking the rock cores. This is the double core barrel. This is the single core barrel, and this is the inner barrel, the outer barrel, and inner barrel. So this way we do the, and this is connected with the drilling rod. So with this, we do the coring work, drilling, and then coring in the rocky strata. So in this way, this is a typical core box in which the cores are collected and kept, and rock quality RQD is determined, which is defined as the percentage of rock cores that have length equal or greater than 10 centimeter or over the total drilling depth. This is how core RQD is total core recovery, and RQD is defined. This is suppose core recovery. This is 25 centimeter. Then again, these are the different cores, the size of the cores, and this is the modified core recovery in which all the cores of length having less than 10 centimeter has been neglected. Just see. So if we consider all the cores, then the entire length, entire core length in one go will be 125 centimeter. If we do it modifying the core length, then it will be 95%. So this will be this 125 to 150, that is 83%. This is the total core recovery, while this 95 by 150, that is 63%. This is the RQD, rock quality designation. So with this RQD value, we are having we can get the idea of what is the rock mass quality. If RQD is less than 25, it means it is very poor quality of rock mass, and if it is 99 to 100, then it is 90 to 100, it is excellent. 75 to 90, it is a good. Then poor and fair. So this way, after getting the RQD value, we can get the we can say ki this is the type of, this is the quality of the rock. So now, after getting the core recovery, core drilling and RQT, we do the testing, UCS and other observation, and then we calculate the this RMR. So as per RMR, how I'm going to tell how this RMR is being calculated. This is RMR is the sum of many this numbers, priority numbers or rating numbers, and which is given for for the various properties of the rock. Suppose one is the R1. This is the rating 1. This is R. This is based on RQD. If RQD is excellent, then we give the rating of 20. If it is in the very poor condition, means RQD is less than 25, then we give the least rating. So R2, this is for the strength of intact rock material. If it is exceptionally strong, we give the higher rating. If it is very weak or extremely weak, if it is extremely weak, we give the 0 rating. And if it is weak, then we give it 2. So this is the rating based on the UCS value. Now spacing of discontinuities, that also gives a rating. And if spacing is very wide, means joints are not closure, they are very wide. So for that we give the maximum rating, and if it is very close, means very closely jointed rock, then we give the very less rating. Now, what is the condition of discontinuities? Depending on that also, whether it is very rough or unweathered, then we give the maximum rating. And if it is a 5 thick, soft gauge, continuous discontinuity is there, then we give the rating as 0. So groundwater condition, depending on that also we give the rating. If it is completely dry, we give the maximum rating. And if it is flowing condition, water is in the flowing condition, then we give the minimum rating. Then we do the adjustment for discontinuities orientation. If it is favorable, then we give the maximum minimum reduction, and if it is unfavorable, we do the maximum reduction. So finally, our RMR is the summation of all these ratings, and we sum it, and then we get a number which is called the RMR number. Based on this RMR number, we get the net bearing pressure of the rock for the foundation. So if and we classify also, if RMR is 100 to 81 to 100, then it is a very good quality of rock. Classify it as number 1, first type of rock. And if it is very poor, 0 to 20, then it is a very poor, and then we give the classification as 5. Number 5, and accordingly we this relation is there. If it is very good, then we get the bearing pressure 600 to 448 ton per meter square. And if it is very poor, even then the minimum say bearing pressure is, let's say bearing pressure is 40. So anyway, in the rocky strata, whatever be the rock condition, we are going to get 40 ton per meter square as the net safe bearing capacity. Now PLT, plate load test, we do the investigation just to confirm the bearing pressure adopted for the foundation design. For that, we conduct the plate load test, and we get a relationship between the applied pressure and the settlement of the plate. So this is not a very preferred testing method, because in this case plate size and shape is having its own limitation. You can see this is a typical arrangement for conducting the plate load test. And drawback is like this: we are conducting a plate load test over this found plate size, which is having this 2V as the influence zone, and corresponding to this, we are going to extrapolating this data to the actual footing size, which is having this much size. So for this is having a bigger influence zone. Suppose this upper layer is stronger, and below that there is a soft material. So in that case, we will get a plate load test data as misleading. We will not, that will not be valid for the design of this actual footing. So this is the limitation of the plate load test. Normally we don't do, but for the small size foundation, a verification can be done using this plate load test. So after conducting these field tests, we go for the laboratory. We do the laboratory testing, different laboratory testings for classification, chemical test, compaction, shear strength test, consolidation, then permeability test. Then we do the rock test on rock, then contamination test, soil and water testing, then do the rock testing, chemical, again contamination. With after doing the field test as well as the laboratory test, we go for the report preparation, in which we describe the site condition. A description of nature, type, and importance of the proposed construction is given in the report. Description of field and lab test is carried out. Analysis and discussion of data collected. Preparation of chart, table, graph, etc. Calculations performed. Then recommendation. We go for the recommendation. So after doing this, one most important parameter is that which should come in the report is that the evaluation of liquefaction susceptibility position. After conducting the investigation, we should be in a position to say that after a seismic loading condition, whether our strata is going to liquefy or not. So that analysis should be done, and we should be sure that there is no liquefaction in the soil strata. Then only we can put the foundation over that. In other words, our foundation should never lie on the liquefiable strata, because in case of liquefaction, the structure will collapse. So, how we do the liquefaction analysis? Earthquake loading that creates cyclic shear stress, and liquefaction resistance, which is a symbol of strength, that is from the cyclic shear resistance. So, cyclic shear ratio, cyclic shear stress, that should be more than the cyclic stress ratio. Cyclic resistance ratio should be more than the cyclic stress ratio. Then only we will get the factor of safety against liquefaction as more than 1. So for that, this is a method how we calculate, determine the cyclic stress ratio. This is 0.65 gamma h A max by G by RD, where A max is the maximum peak ground acceleration, which is anticipated in case of um, the earthquake. So when earthquake comes, what will be the maximum peak ground acceleration? Depending on that, we calculate the average shear stress. And cyclic shear stress is the average shear stress divided by the total effective shear stress. So in this way, we calculate the CSR. Then we have got the strength parameters after this field test and laboratory test. So based on that, at different depth, we calculate what will be the cyclic resistance ratio, means the resistance offered by the soil strata in case of liquefaction. So this is the certain procedure which is given in the IS code, and on that basis we calculate the CRR, and finally this is how we calculate the CRR, and finally we get the factor of safety against liquefaction as the ratio of these two. This is a typical sheet where we have at different depth we have calculated the factor of safety against liquefaction, and on the basis of that we have declared whether our that soil is susceptible to liquefaction or not in the case of earthquake, in earthquake condition. Here, one point is that C60, if we do the SPT as per standard way, or 60% energy is transferred to the split spoon sampler, then we can say C60 is 1. Otherwise, if it is different than that, then we have to do the different calculation of C60, because this energy ratio will change. So this is how we calculate we determine whether our strata is prone to liquefaction during earthquake or not. If it is not prone, then we can say we can put our foundation over that soil. Now, I will show you some infra projects, and corresponding to that, what type of foundation have been adopted globally. So you may be seeing a lot of structures, but you may not know, yeah, you may not imagine what type of foundation has been provided to that structure. So as a civil engineer, you should know that, and I am going to give you some descriptive description of some structures and their corresponding foundation types. See, this is a project, Senton Way in Singapore. This type of building is going to be constructed at this place, and the type of foundation to be adopted or has been adopted as the rock socketed pile, which has been of diameter 10 to 1000 to 1600 mm, which is socketed up to 10 meter into the boulder with clay layer. So this is a structure, and corresponding to that, the foundation is the rock socketed pile of 1000 to 1600 mm dia and socketed 10 meter into the ground. So this is a this is another office building to be constructed at Singapore. The foundation type is rock socketed pile, board pile, socketed 10 meter into the bouldery clay layer, and diameter is 800 to 1800. Now this is the Royal Domain Tower in Melbourne, Australia. For that also the foundation is a deep foundation, socketed pile, and die 750 mm to 1500 mm socketed into the rock. And this is a Melbourne cricket ground, Australia. For this structure also, piling has been done, and 600 to 1800 mm diapile and 25-meter deep into the rock. This is another station redevelopment in Sydney, Australia. Here also the board pile has been used, 600 to 1500 diameter, socketed into siltstone rock. This is another mega project, Shenzhen Ping and Center, SPC Center in China, where 606-meter tall commercial building has been constructed. And diameter here, the foundation type is the rock socketed pile. Diameter of the pile is, you cannot imagine, it is 8 meter to 9.5 meter, 8 meter at the top and 9.5 meter at the bottom. And total length has been taken as the 37 meter. There were so many issues for even for excavation and concreting of the pile, and how cooling of the concrete means heat generated from the pile concreting, because that was a very huge huge piling work, huge concreting work. So for such a large concreting work, heat of hydration is too much. And just to cool down that thing, special arrangements or special construction techniques has been adopted. And the geotechnical condition was that sedimentary clay soil and sand underlain by completely weathered rock to slightly weathered rock were found, and up to 37-meter deeper deeper pile has been constructed using this used at this site, just to construct the 606-meter tall building. Another important this unique structure is Millau Viaduct, that is in the France. This is the tallest cable-stayed bridge in the world. This is constructed over a valley of River Ton. Each pier composed of four RCC piles with diameter of 5 meter and socketed length of 10 to 15 meter. That is, socketing length is 2 to 3D and bonded together at the top by a 3.5 meter thick reinforced concrete footing. Means pile cap itself is 3.5 meter thick concrete. So over that, this pier has come. This project is in our country, in Delhi, signature bridge in Delhi across river Yamuna. This is an asymmetrical cable stayed bridge. 154-meter high viewing box has been constructed, and this is 575-meter long. Most of the foundations are well foundations, but some foundations are constructed with a 2-meter diameter piles inside the well, socketed into the rocky strata. What has happened when they were constructing they were just installing the well foundation, then they were not getting a uniform rocky surface was very undulated from at the different. So just to make it a plain resting level, they did the rock socketed pile. Over the pile cap, they rested this pile well foundation. So this was also a very typical foundation for this large structure. This is a structure of Vasoli Bridge. This is a bridge over River Ravi. Out of 592 meter, 350 is a cable stayed bridge. Two towers are constructed on rock socketed pile. Diameter of the pile is 2.5 meter, socketed. Length as 26 meter. Here socketing length is 10.4 D. Normally it's an exception as given in the codes, different codes. Then Chenab Bridge, very large bridge over Chenab River between Bakkal and Kauri of Jammu and Kashmir, is under construction, is expected to be completed in, I think, 2023. And this is the world's highest rail bridge. It is a large span arch over the river. And the foundation type is the raft foundation. A huge isolated foundation has been provided for this bridge. Now I will come to some case histories. RTR flyover New Delhi. We had done long back. We have done the investigation for this RTR flyover. This was a very ambitious project of Delhi government. Length is 2.7 kilometer. The cost was tendered cost was 310 crore, and its location was branches of Munirka flyover in South Delhi and ends at Army Research and Referral Hospital on Outer Ring Road. Anybody going to airport will be benefited, and from the Delhi or South Delhi or Central Delhi or any part of the Delhi and NCR, they will be benefited. So for this project, we had done the investigation. In 2.7 kilometer, we had done 10 boreholes. Boreholes were done at each and every pier location, but just representatively, I have taken the data of 10 boreholes and summarized those data. And the challenge during the work was that there was a scarcity of the working space. Survey drawing of authentic underground utilities, that is ST cable, CNG gas pipeline, were not available. Where it was showing the no ST line, ST cable, or CNG pipeline. When we used to do we started doing the drilling, we got a ST line. So we had to change the space, that location. So just to fix the location where we have to do the investigation, we have to be sure that there is no ST line, there is no CNG gas pipeline, by just hit and trial, because there was no authentic underground utility available. Traffic diversion, that was also a problem for this project. So this is a typical arrangement and typical way how we conducted the investigation at this stretch. There was a very heavy traffic, and just to take care of heavy traffic as well as the this underground utilities, a lot of exercise has to be done. So that is the challenge for conducting this investigation. Geological surprises was encountered in Munirka area where subsoil variation had been observed in a stretch of 2 kilometer corridor. Different even in 2.7 kilometer stretch, we have found a lot of variation. You can see here complete soil strata up to 40-meter depth. Here in some in borehole, we got this rock as in deeper at deeper position. Here again, this soil cover is reducing. Again, soil cover is increasing. Here, full soil. Then again, soil cover is reducing, again reducing. Here, the this thing rock is at the surface itself. So, from this such type of variation, what we had to do, we cannot make a tab on the foundation design. So, each and every location has a different and unique subsoil strata. So for corresponding to that, we had to do the foundation design. So this is the rock course which we have collected in the core box and kept in the core box and classified, labeled everything. So with that, after doing that investigation, what we concluded, what foundation was proposed was that here pile was provided having 400 capacity as 450 ton at a length of 20 to 25-meter depth. Length means total pile length was 20 to 22 meter, and we could get pile capacity as 450 ton. Here with 18 meter depth only, we got the same 450 ton capacity. Here at 11.5 meter only, we got the pile capacity of 450 ton. Here again we have to go 20 to 22 meter. Again this is at the same depth at and here what we got here we the entire construction was done using the silo foundation, raft only, open foundation. With the open foundation, we got the required strength of foundation. So here open foundation, here soil pile socketed in the soil, here pile rested on the rock. So all three type of foundations were given and were proposed, and those were constructed also to get the structure completed. So there was a large subsurface strata variation. Almost every borehole has a different subsoil strata where rock level has been encountered at varying depth. At the time of execution, even variations were found within a pile group. Even within a pile group, variations were found. So we have to do in a pile group again. We had to do the some borehole, and we have to decide what is the what is the depth of rock encounter. So no uniform tab on the design process can be kept. Even the execution methodology for each location was different, which obviously has a great impact on the project cost and time. This project was delayed also due to so many irregularities, not only administrative but from the geotechnical point of view also. Now another high-rise building complex at Greater Noida. This is another case history. Multi-story residential tower in Transcendent area of Noida, NCR. Total number of floors 35 with single basement for parking purpose. This is the borehole location plan for the phase 1. This is how investigation was done. This is the type of strata which we have got after doing the investigation, and 6 type of layers. In such strata, the pile foundation was proposed, and this is the summary of the investigation regarding the strata as well as the unrecorded and uncorrected. We can see here after 12 meter the strata is quite strong, and pressure meter test was also conducted, and various parameters, soil parameters were inferred from that test. Pile load carrying capacity of the pile was calculated, and it was executed. During the execution, as I usually used to say to the client, that getting the pile capacity is not only the theoretical or investigation issues, but how you are going to install the pipe. That is the main thing, which correspond to the getting the required load carrying capacity of the pipe. In a same strata, if your execution is very good, you will get 600 ton capacity. If your execution and base washing is not good, then you will not get even 350 also. So entire success of the piling work depends on how well or how nicely you install the pile and get the execute the pile. Now pile load test was done. This is the typical way of doing the pile load test. Then this is the graph, load versus settlement. And in this, we can say up to 525 working design capacity of the pile was obtained. And corresponding to that, 1285 ton capacity has been got. Now, this is another site in Bihar for the railway line for DFCC. Different type of, and here investigation was done, and entirely different strata were obtained as anticipated at different locations. This is the strata what we had got, and expandable clay was encountered in the upper layer. So when the construction or foundation design was to be recommended, then for the light building, under reamed piles were provided. For the heavy structures, raft were provided, and for the viaduct, etc., box or raft or pile or well, such type of foundations were adopted for the. When we visited the site, we saw a building. There were residential colonies also, starting from 2 story to even 4 story. In the small story buildings, we have found this type of cracks, and when we increase the this number of story or the loadings, then these cracks were not found. The it can be inferred that this swelling pressure was encountered with the applied load from the building. So in the larger in the four-story buildings, no cracks were found because this pressure was balanced. And in case of small buildings, the cracks were very conspicuous because swelling pressure was not encountered. So this is the story of these structures in soil having clay strata or expensive soil in the upper layer. When though in the lower layer, lower depth, the strata was good and non-expensive. This is a bridge over Narmada at Ankleshwar. This is a very typical bridge constructed as is being constructed. This is in the final stage of the construction, and it is being constructed as 284-kilometer chainage. 284-kilometer chainage. Total length of the bridge is 2220.05 meter. Span arrangement, this is a extra dose bridge. Span arrangement, that is 16 span of 48 meter 48 meter span length. Then 4 extra dose spans of 75 plus 120 plus 60. This is the 4 extra dose spans. And then after that, it is 9 spans of 48 meter length. Number of carriageway 2. Total width of the superstructure was 21.25. This is the specification of the bridge. What the relevant data from as a geotechnical point of view is that there was a scouring level at the scouring depth at the pier location was 25 meters. So it was a big challenge because this is a bridge across the river, and in this river, up to this extent, of waves from the sea used to come. So this is the tidal effect is also to be taken care of during the investigation. Many times we try to do we try to fight this tidal effect in the river, and ultimately we could do the boreholes in the water also. And for this, you can see this is how the area looks like, and the bridge is being constructed, and this is in the final stage. I think final for this finishing of the superstructure is not completed, so we are not able to get a proper means finished photograph of the bridge. But anyway, this is a very landmark bridge, and for this we did the investigation at corresponding to a particular pier location P11. We got this strata up to 2.5 meters. It is a silty sand which is having n value, average n value 19. Below that, n value is very high. It is medium dense to even densest state, and did the investigation up to 70 meter. And with this data, the pile capacity was calculated, and diameter of the test pile that has been taken as 1600 mm, 1.6 meter. Total length of the pile below cutoff level, that was 52.5 meter, out of which 25 meter was the scouring depth. So that was an unsupported length of the pile. So grade of the concrete, that was M40. Reinforcement is vertical 32 dia and helical 20 mm dia bar. Date of casting, and after 28 days of the concreting, the 28 days cube strength of the concrete, which design was 44.75 megapascal. Then initial vertical load test was done. The loading method was cyclic, and working load working load was 1000 ton. So we need to do the testing up 2500 ton. Total load applied vertically, it was 25.4 2504 ton. Number of jacks 8 number, capacity 2800 ton. Ram area was this centimeter square. Then pressure gauge 0 to 1000 kg per centimeter square, that pressure gauge was used. Number of dials 4. Total settlement obtained was 11.37 mm, corresponding to 2504 ton vertical load, and the net settlement was 5.96 mm. Rebound settlement was 5.41 mm. So this is a typical arrangement for doing the load test of the pile. This is the graph of a settlement, applied pressure versus settlement. You can see here 11.38 mm total settlement corresponding to 2504. So this is how piling was done. Initial pile load test investigation was done. Then pile capacity was determined. Then the initial pile load test was done, and the determined pile capacity was validated by the load test. And the bridge is almost completed, and very soon it is going to be inaugurated. This is another bridge over Narmada at Hosangabad. This is very far from the Ankaleshwar. So here the water pressure and water flow is quite less. This is constructed in MP, Hosangabad. And for this 25 span, 36 meter, only 900 meter length of the bridge was there, two carriageway. And the significant data for geotechnical aspect is design scour depth. Here at the pier location was only 7.5 meter. There at the Ankaleshwar it was 25 meter. Now here it is around 7 meter, 7.5 meter. Type of structure, precast box were used, and it was a 6-lane bridge. So this is how investigation was done. We had done the investigation. You can see, even you can cross the river during in some time of the year. You can cross the river even by foot. And but when the peak flow is there, then everything is filled with the water, huge water. So for that, investigation was done up to 40-meter depth, and such type of this is the type of strata which we had found. Corresponding to this, we had done the scouring depth 7.5 meter. We have done the calculation for the uh, this pile capacity. Pile dia was adopted was 1200, while there it was 1600. Here it is 1200, and length is 25 meter only. So this is a typical structural drawing, and typical this foundation level. This is the normal ground EGL. This is HFL. This is the length of the pier and corresponding pile cap. Then again, this is the pile. This is the another end of the this bridge. This is a typical pile cap plan where you can see 6 piles of 1200 dia were adopted, and this is the typical design. 450 ton safe capacity has been taken, and point load, this initial load test has been done for 1125 ton capacity, and from the initial load test the pile capacity has been achieved. This is how constructed pier looks like. This is the pile, and this is a longitudinal section. This is a pile. This is pile cap, 2-meter two meter deep pile with pile cap. Then over that it is a pier, and then it is a superstructure. This is how it looks during the construction. This is the photograph showing the bridge, steel girder bridge. Now another office complex. This is a typical office investigation for the office complex at Noida in Film City. Many boreholes has been done. A maximum depth of the borehole was 40 meter. DCPT test was done. It is in seismic zone 4. After the investigation, we got this strata. This is the description of the strata. Then this is the different test test values, n values, n recorded and n corrected. Then water table was found at 15-meter depth. Then no liquefaction potential was found up to the 40-meter depth. Then design parameter at 1.5 meter and 14.5 meter. These are the design parameter. Weighted average value of n for shear for settlement. For shear we have adopted 1b. We have taken the n value up to 1b, and for the settlement it has been taken as 2b or 1.5b. So parameter what we have adopted, that is given, that has been chosen uh, cautiously, and for that calculation has been done. For the isolated footing, total settlement allowable settlement was 50 while for the raft it is 75 and this is the open foundation recommended. And this way the pile capacity has been calculated and it is recommended for the proposed construction. So the cutoff level, this load capacity of pile is based on a static formula using IS code. Then another, this is a highway project where the structure where different structures, different bridges were constructed as different changes. You can see at near 1 kilometer, then at 5, 9, then 10, again 165, up to 165. Different boreholes up to 40-meter depth, from 30 to 40-meter deep boreholes, different numbers. See, initially what I had said, means here is for this bridge span was this much. So we had done 23 borehole 30-meter, then 16 borehole 40-meter. Here span is three span of 33-meter. Though then only we did 4 boreholes of 40 meters. So our depth and number of borehole, that depends how small or how large the construction, the superstructure is going to be constructed. This is a typical Ganga bridge. This is the machine which we use, DTS machine we use to do get the strata profile. It's a profile of the strata in near Haridwar in for the Ganga bridge, at Haridwar for the Ganga bridge. So this is a typical strata. This is boulder strata. This shows at 0 plus 700 boulder was found up to even 17 meter. Below that, alluvium was found. Alluvium soil, sandy silt or silty sand were found. So from Haridwar to Kasipur, when we are moving up to 29 kilometer, from Haridwar to 29 kilometer, we got this rocky strata because it is a foothill area. When we are moving away from the foothill area, you can see how the strata is varying. This bouldery strata diminishes when we move away from the foothill. So this is the different foundation proposals which we have given for the Ganga bridge. We have given the well foundation. So entire structure for the all the structures we have given either well foundation or the pile foundation of different depth and different length. So this is how we do the investigation. We arrive at the subsoil parameters and we characterize the subsoil, and we do the foundation design, execute the foundation, and see the uh, evaluate the different predictions after conducting the different test or monitoring test and all. And even after so many advancement and everything, structural failures are also there. This is a typical retaining wall failure along the railway line. Leaning Tower of Pisa. It is a classical example of neglecting the geotechnical investigation, then sinkhole. But that neglect made this structure a world famous. Bridge failure, even before inauguration, everything was done, investigation was done, pile was recommended, but execution of the pile was not proper. So there was no proper integrity of the pile. So pile failed, pile sank, and due to high flooding, pile sank because scoring was there. That aspect has not been thought of or some maybe due to some accident and all, this took place, and the result is in front of us. Thank you for patiently listening the presentation.
Thank you so much for the extensive and very detailed presentation. I think the videos will be very useful for the students.
Yeah,
uh, because they are doing the soil mechanics lab and which has SPT and other things. Some of them are here, I think. So it was so difficult for us, so you try to show that it was really great help for the students to understand the significance. And so thank you so much, Dr. AP Singh, for giving such a extensive uh, thing for the student perspective. So it was really great information for all of us. Thank you so much. So with this, like, if there is any uh, discussions or any questions from the students, so kindly we can take couple of them from the participants. Is there anything you want to discuss, ask, like whatever?
I think how contamination testing done in laboratory. Okay, this is a environmental
Yeah,
issue.
it's environmental engineering.
Yeah,
What contamination?
yeah. We can decide this rating on the basis of geotechnical software. We can decide this rating on the basis of geotechnical software. But physical observation is very important. How you are going to use software. So for that, you need to give this observation. I think only two questions were there.
Yes, yes. In chat we had only two.
Yeah,
So that's all. Like, I your contact details will be shared with all the
yeah,
participants.
sure.
If there is anything, they can contact later also.
Yeah.
So the database. So thank
Anytime they can contact.
yeah.
And this lecture is mainly for the students, because